Cloud-native architectures such as microservices are becoming the default standard in the software industry. Yet, when you're building these kinds of solutions, things get pretty chaotic very quickly. In this course, I'm going to show you a number of tactics to create advanced and robust microservices with ASP.NET Core, domain-driven design principles, event-driven architecture, CQRS, event sourcing, and of course, Azure. Hey there, I'm Rodrigo Díaz Concha. I'm part of the Microsoft Regional Directors Program, and I've been awarded as Microsoft MVP for over a decade. I'm convinced that the best way to learn is by doing, so I created an entire microservices solution, and I included some hands-on challenges that help you practice the technical concepts and ideas. There's a lot to learn, so let's get started. To get the most out of this training course, you need to already have some experience working with the .NET platform, ideally version 5 or above. This course assumes that you've been using the C# programming language for some period of time. We'll be using C# version 9 because of its record types and init-only setters. Thus, I'm not going to explain the syntax used in the companion code for this course, at least not in these videos. You should also be familiar with both the ASP.NET Core Web Development Framework and the Entity Framework Core Object Relational Mapping Framework from Microsoft. All of the microservices that we're going to build in this training course are based on these technologies. On the other hand, we'll use Visual Studio as our main development environment. But since .NET is a cross-platform technology, you could easily use any other supported editor you like. Another important topic that you should be aware of is Docker and Docker containers. We're going to pull and run some Docker containers by the end of the course. I'm also going to assume that you understand the core principles of domain-driven design and its most important artifacts and tools such as bounded context, ubiquitous language, aggregates, entities, value objects, and domain events. Also, I'm going to assume that you know the main traits of microservices. However, I included a microservices refresher video in this same chapter. We'll use the Azure Cloud and some of its platform as a service products such as Azure Service Bus, Azure Cosmos DB, Azure SQL Database, and Azure Functions. To that end, I assume that you have an active Azure subscription, you know how to provision resources in it, and you're familiar with these platforms, at least at the basic level. Finally, in the cross-cutting concerns chapter, I'm going to use Elasticsearch as a logging storage. Elasticsearch is part of the ELK stack. I don't expect you to be an expert in the ELK stack, but you should at least know the gist of it. But don't worry if you're not familiar with it, I'll explain as I demonstrate. If you're comfortable with these subjects, then you're ready to begin the course. In this video, we'll touch upon the core microservices principles. We can define microservices as independently deployable, loosely coupled, and autonomous services. I personally like this definition because it includes the main traits of this architectural style. Just like any other architectural style, microservices have some pros and cons. I can't stress enough the importance of knowing beforehand what you're getting into. I've seen so many different teams fail in their microservices journey due to a lack of detailed understanding of their benefits and challenges. Okay, let's talk first about their pros. Microservices give you autonomy in terms of the ability to deploy or replace a single service instead of redeploying an entire monolith. Also, they enable autonomous teams by preventing decision contention. In a monolithic architectural style, most of the time you can scale vertically or horizontally. For the latter case, you run more copies of the application. However, not all the components have the same compute requirements. On the other hand, microservices could be scaled independently. Since you build a scoped functionality, microservices could have better maintainability. Failures happen all the time, and in distributed applications, there's more room for problems. We can describe resiliency as the ability to recover from failures and still remain functional. If you truly follow the loosely coupling principle of microservices, you could have a more resilient system. Now let's talk about the downsides. Please be aware that I have only included 2 in this video, but I'm sure there are more than that. The first one is that microservices are more complicated than a monolith. Due to their distributed nature, microservices are more likely to suffer from the fallacies of distributed computing. On top of that, microservices are more difficult to design in terms of their proper boundaries. Perhaps you've heard the question, how small should a microservice be? If you don't correctly design your microservices, you could have a distributed monolith at the end of the day. Secondly, you must be willing to manage eventual consistency in your data if you really want a performant application built with microservices. Of course, you could have a strong or strict consistency, of course, in some parts of your microservices only, but generally speaking, it's almost impossible to have it in the entire application. In fact, that actually defeats the whole purpose of microservices. I briefly mentioned how a wrong microservice boundary could lead you to a lot of problems. Well, domain-driven design can help you in that matter. You could benefit from DDD principles and tools to design a well-architected system. Also, it could be more aligned with your customer's vision. DDD guides you to write clean and reusable code and focus on what's important for the business. Through the use of bounded contexts, context mapping, and a ubiquitous language, you could design not only better microservices, but better software overall. Speaking of the ubiquitous language, I can't stress enough its importance when designing microservices applications. It helps you remove all the uncertainty and gives you a common ground between all the members of the technical team and the domain experts. DDD's principles and tools can be used along so many different software architectures. For example, the hexagonal architecture or the clean architecture. Both of them are very similar and they propose the same principle, a clean separation of concerns. At the heart of these architectures is the domain model or domain logic, which has the core business logic implemented as entities or aggregates in DDD terms. The application services include the task coordination logic among aggregates and also the use cases implementation. Finally, we could find all the infrastructure components in the outermost ring, such as concrete repositories. As a microservices developer or architect, you should address the challenges related to communication between microservices. In the microservices architectural style, there's always the option of communicating synchronously between services. Even though this communication pattern is quite easy to implement, it has some disadvantages. For instance, when one of the downstream services fails, all the upstream services will fail too. Now that we've gone through this refresher video, let's move on. Throughout this course, we're going to build a small part of a microservices solution for Wisdom Pet Medicine, a veterinary hospital and pet grooming company that has been increasingly growing its businesses for some years now. As a result, the company has decided to build a new system capable of supporting the current and future operations. From their website, Wisdom Pet Medicine strives to blend the best in traditional and alternative medicine in the diagnosis and treatment of companion animals. In addition to the regular veterinarian and pet grooming activities, the company is interested in bringing a new rescue division into their daily operations, based on the great work that Dr. Chase has been doing in her free time. As part of the analysis phase, we, the IT team, suggested having an event storming session to obtain domain knowledge and deeply understand the requirements for the new system. After an initial event storming session that included the domain experts in the company, we identified the different events that happen in the processes, the commands that triggered those events, the logical set of entities that belong together, and some required views for user interfaces, reporting, and external systems. The event storming session helped us to detect 3 contexts for the solution: pet, rescue, and hospital. Thanks to the ubiquitous language that came up from the session, we learned that a pet has different meanings and names within the context. For instance, it's a patient in the hospital context, whereas in the rescue context, it's a rescued animal. Things are looking good, and I think we're all on the right track now. Let's move on to explain what we're going to build. Let's describe the things that we're going to build. To get the most out of this training course, I've already created some code to speed up the learning experience and also be able to balance the course length. We have 3 microservice projects built with ASP.NET Core. These microservices are Pet, Rescue, and Hospital. In Chapter 1, we'll implement code to communicate between microservices in a loosely coupled fashion. For this, we'll use Azure Service Bus, topics, and subscriptions. The Pet microservice stores its data in a SQL Server database by using the Entity Framework core. It publishes some event messages to Azure Service Bus that are asynchronously brokered to the Rescue and Hospital microservices. Just like the Pet microservice, both Rescue and Hospital use a SQL Server database and the Entity Framework core to persist the incoming events data. In Chapter 2, the CQRS pattern, we'll expand the current code base to add some commands and value objects, and we'll create a new Rescue Query microservice. In Chapter 3, Event Sourcing and Microservices, we're going to store the individual events of the patient aggregate in Azure Cosmos DB. Then we're going to create a new Azure function that automatically obtains the created items. In other words, the patient events. We're going to implement some code to project the current state of the patient entity to a SQL Server database. Finally, we'll add a new patient query controller that takes advantage of the projected data. In a microservices system, it'll be ineffective for a client application to communicate to each service directly. That's why, in Chapter 4, API Gateway, we'll build a new API Gateway service that could sit in the middle of the client applications and the rest of microservices. Last but not least, we're going to add some cross-cutting concerns in our microservices, such as versioning and centralized logging. There are countless ways of designing software, and actually there's no such thing as a perfect software architecture. Regardless, the code of this course follows some principles. The code implementation is inspired by domain-driven design principles and tools such as bounded contexts, aggregates, entities, value objects, and domain events. Also, the code implementation is pragmatic. That is, we're going to focus on the topics rather than on the details. For example, when handling commands, we're going to directly use an application service object and its methods from the controllers. This leads me to the following principle. We're not going to over-engineer the code. In real-world scenarios with microservices, sometimes it's okay not to follow some principles such as dry. We'll try to avoid accidental complexity at all costs and avoid adding extra layers of indirection. We'll try to reduce the usage of third-party frameworks or libraries. While there are numerous frameworks that we could use, I believe they could distract us from the things that really matter. Finally, one of our main goals will be to implement truly autonomous services. That's precisely one of the reasons for using microservices in the first place. Let's dive deeper into each microservice. The Pet microservice uses the Pet entity where all the domain logic is implemented. This microservice is able to receive commands to perform some actions and processes in the Pet domain model, and it also exposes a query. We can consider the Pet microservice as the core microservice in this course. This is because it publishes the required events for the other microservices to be useful. As I've already mentioned, it uses the Pet database that is a SQL Server database. The Rescue microservice uses the rescued animal and adopter behavior-rich entities. In addition, this microservice exposes some endpoints capable of receiving commands. Furthermore, it handles one of the integration events that the Pet microservice publishes. The database of this microservice is Rescue, and it's also a SQL Server database. The goal of the Rescue Query microservice is to expose an endpoint that returns data from the Rescue database. As you can see, both Rescue and Rescue Query microservices use the same database. Don't worry, this is okay when using the CQRS pattern. Again, pragmatism is the name of the game. The Hospital microservice uses the patient and procedure entities. In fact, patient is an aggregate that internally uses the procedure entity. The patient aggregate tracks all the domain events that happen. This is an essential trait of this aggregate since it'll be the basis for implementing the event sourcing pattern. Similar to the other microservices, Hospital receives commands, exposes a query, and handles an event. The event storage for this microservice is an Azure Cosmos DB database with a single container named Patients. The hospital projector function is triggered automatically by the Azure Cosmos DB change field. This function rehydrates the state for a given patient, and then it stores the more current state in the hospital database in SQL Server. That's precisely the patient query data source. Lastly, let's discuss what's out of scope. In the code, we're not going to deal with transactions when persisting data and triggering events. We're not going to deal with deployment tasks. However, that could be a straightforward task, mostly if you were to use Docker containers for your microservices. Finally, we're also not going to deal with security topics such as authentication or authorization. Well, that sums up what we're going to build. This is going to be fun, isn't it? Let's talk about preparing the development environment for this training course. First and foremost, we need an Azure account to provision the required resources. If you happen to have one already and you want to use it, that's fine. But if you don't, then you can create one for free at azure.com/free. This is an advanced course, and we'll spend most of our time inside Visual Studio and use its out-of-the-box features. However, there are some additional tools that we'll use. Let's see the full list. In this course, we're going to use .NET 5 and C#9, which are the latest versions of these technologies. You could also use newer versions if, by the time you're watching this course, they are officially available. As I've already mentioned, we're going to use Visual Studio as our code editor, but you could follow the course and complete the challenges with any other supported IDE, such as Visual Studio Code or JetBrains Writer. In Chapter 3, we'll build an Azure function. To that end, you need to have Azure Functions core tools installed on your machine so you can build, test, and debug the function. By the end of the course, we're going to use some Docker container images. Thus, you'll need Docker for Windows. If you're using Linux instead, then you'll only need the Docker engine. Finally, we're going to use SQL Server Management Studio for data exploration and querying when testing the microservices that use the SQL database engine. Another option could be Azure Data Studio, which is an open-source, cross-platform data management tool. Let's now describe what an event-driven architecture means for a microservices solution and how it would look like. Event-driven architecture is all about enabling asynchronous collaboration between microservices. It contrasts with the synchronous communication pattern that we can easily implement between two or more microservices. The main problem with this pattern is that when you directly communicate to a service from another service, it creates a temporal coupling between those two. And any kind of coupling is precisely what we would need to avoid when building robust and scalable microservices applications. We should always strive for autonomous services that could be deployed in isolation without impacting other services. The truth of the matter is that if a microservice relies on another to fulfill a request, then it isn't truly autonomous. As you could imagine, the problem worsens when more than two microservices are involved in the same chain of requests. For example, what happens in this scenario if service C fails? It'll create a domino effect that goes back to the original caller. That's precisely why, most of the time, it's a better idea to have asynchronous communication between services based on events. In this architecture, we always have three main elements. Event producers that create events. These events originate from the domain logic of the application. Oftentimes, the event producers are not aware of which components or services are interested in receiving those events. The second element is indeed the event consumers. And the third element is the event broker platform or application that we use in our system. There are so many different products in this category, and all of them have the same goal: to enable loosely coupled communication between services. To accomplish this, the event consumers subscribe to a particular event or set of events that they are interested in. When the event publishers actually publish one of those events, the consumers receive the event and its related data. In this fashion, we could have dozens, hundreds, or even thousands of microservices receiving events, in a loosely coupled way. This is one excellent way to achieve true autonomy. As I've already mentioned, there's an abundance of platforms and products that perform the same goal of asynchronous sending and receiving of events. However, in this training course, we'll use Azure Service Bus. Technically, we provision an Azure Service Bus namespace, and inside the namespace, we create topics. We could also create queues, but that's out of scope in this course. After creating the topic, we create a subscription for that particular topic. Then, our microservice application communicates to the subscription to publish or consume the events. Now is the perfect moment for you to provision your Azure Service Bus namespace that you're going to use in this course. Please be sure to create the following topics and related subscriptions. There are two other concepts that I'd like to discuss: domain events and integration events. Both of them are essential topics in domain-driven design, and we use them a lot in the companion code of this course. Both domain and integration events represent facts in the domain logic. In other words, something that happened in the past, something unchangeable. The difference is in the way that we handle those events. For instance, domain events are handled in process and trigger side effects in the same domain, whereas integration events are handled out of process and trigger side effects in a different domain. Additionally, domain events are created in the core domain layer, whereas integration events are created in the application layer. Of course, there could be many different ways to implement them. However, this is the way they're implemented in the code. Okay, you've already seen a bit of event-driven architecture. Now it's time to roll up our sleeves. In this video, we'll handle a domain event. This event is triggered when a user flags a pet for adoption. We're going to handle the event in the pet application service class of the pet domain project. Okay, let's fire up Visual Studio and let's open the solution. Here we are in Visual Studio, and let me show you the event that we're going to handle. That is right here inside the pet domain project. Events, right here, pet flag for adoption. This is the event. As you can see, it's a class that implements iDomain event, and it has different properties that we're going to send over to other microservices that are interested in this data. Okay, we're going to handle this event inside the pet application service class that is inside the pet API project. So right here in the constructor, I'm going to type domain events, which is a static class that is inside the pet domain project as well. And I'm going to use this field that has this register method. It allows me to pass this action of pet flag for adoption. I'm going to pass just a lambda expression right here. So as you can see, I'm receiving pet flagged for adoption, which is the event that I'm receiving. But actually, we don't want to use pet flagged for adoption outside this microservice because we don't want to leak the domain model. Instead, we need another class. So let's create a new folder here named integration events. And I'm going to create a new class named pet flag for adoption integration event. And this class is going to implement iIntegration event. That is a marker interface that we have in the common project. It's just a marker interface. It doesn't have any functionality. And here we're going to implement the same properties as pet flag for adoption. So let's copy this and paste them right here. So we're ready to create a new integration event when we receive the domain event. So I don't want you to see me typing. Because of that, I'm going to paste the code that I already created. And let me just solve this namespace. Perfect. So as you can see, we're creating this new object of type pet flag for adoption integration event based on the same data that we're receiving from the event. So we can test this by following the flow of execution. So I'm going to insert this breakpoint right here. And let's start debugging. The first thing that we need to do in order to test this flag for adoption event is to create a pet. So I'm going to click on this endpoint and I'm going to click on try it out, and let's create a new pet. Yanni, Beagle, white, brown, and black. Let's say 2011, and this is a dog. Okay, let's execute this. I receive 200, and so we're ready to test the flag for adoption. So let's cancel this and let's scroll down a little bit so we can find this flag for adoption. And let's click on post, try it out, and execute. As you can see, I inserted another breakpoint in the controller. Let's click on F5. And finally, we receive the event inside the code that we just created. We're receiving the data from this pet that we're marking or flagging for adoption. Okay, excellent. Follow me in the next video because we're going to send this integration event to Azure Service Bus. We've already handled the domain event and created an integration event object. Now we're going to send that integration event to Azure Service Bus. The first thing that we need to do is to add a new NuGet package reference here in the Pet API project. So let's select Manage NuGet Packages, and the package is Azure Messaging Service Bus. This includes the API for communicating to Azure Service Bus. Okay, let's install it. Excellent. Now we're ready to implement some code in the Pet Application Service class. I'm going to create a new private method named publish integration event async that is going to receive an iIntegration event object. Also, we're going to receive the connection string and the topic name. So here I'm going to serialize the integration event object by using Newtonsoft JSON. So let's use this JSON convert class, and I'm going to use serialize object, passing this integration event, and let's put this in this variable. Next, we're going to obtain the byte array. Let's say encoding UTF-8 get bytes, and I'm going to pass that message. And now we're going to create a new service bus client that comes from the Azure Messaging Service Bus namespace. And I'm going to pass the connection string that we're receiving. Next, we're going to create a new sender. So client create sender, and we're going to pass the topic name, just like that. And now we're going to create the message itself. So for instance, var message equals new service bus message. And we're going to set some properties such as body. Here I'm going to set it as binary data, and I'm going to pass the byte array. Let's remove this. And let's add the missing namespace. Okay. Now I'm going to set the message ID property to a new GUID. Also the content type, application JSON. Wait, I think it's better to use media type names. That comes from the base class library. And here application JSON. Actually, this is a constant. I think it's better instead of using the hard-coded string. And finally, I'm going to set the subject to the fully qualified name of the type of the event, just like that. Okay, finally, let's send this message by using this send message async. I'm going to pass this message, and we're ready. we're ready to use this publish integration event async method somewhere, and that somewhere, that place is right here. After creating the pet flag for adoption integration event object, we're going to invoke publish integration event async. I'm going to pass this object, and somehow we need the connection string and the topic name. So for that, I'm going to inject iConfiguration. And here I'm going to use configuration, let's say service bus. I'm going to create a new element and connection string, just like that. And for the topic name, something similar, service bus, let's say adoption. I'm going to create a new sub element. And finally, topic name. So let's await this. And of course, we need to mark this lambda expression as async. Excellent. So we need to create this configuration somehow. So let's open the app settings JSON. Of course, I could use any configuration provider from the .NET platform. Okay, here I'm going to paste this code instead of you watching me type everything. It's better just to paste the code. Okay, excellent. So this is the connection string that I obtained from the Azure portal. And of course, the topic name that is named pet flag for adoption. So I think we're ready to test this. So let's click on this start debugging button. And we're ready to click on this endpoint, try it out, execute. It returns 200. So let's go to the Azure portal so we can be sure that the message is there. So here we are in the Azure portal, and let's click on this receive option, and let's select pet flag for adoption. And as you can see, I have some messages waiting for me. If I receive one, another one, now it's empty. Let's go back to the Swagger page so I can send another message now. So here, let's click on execute again, and let's go back to Azure. So here, I'm going to click on this refresh button. And as you can see, we're receiving successfully those messages. Fantastic! Follow me in the next video where we're going to consume the integration events in the rescue microservice. In this video, we're going to subscribe to Azure Service Bus in the rescue microservice. We're going to use the pet flag for adoption subscription so that when the pet microservice sends a message, we will be able to receive it. So the first thing that I want to do is to add a reference to Azure Messaging Service in the Rescue microservice. That's something that we have here in the pet microservice. So I'm going to copy this package reference and let's paste it right here. And now we're going to create a new folder named Integration Events. And we're going to copy this pet flag for adoption integration event class because we actually need the same properties as before. And let's change the namespace. That's because we don't want to directly use this pet flag for adoption integration event. Otherwise, I would need to add a reference from the rescue microservice to the pet microservice, but that's not a great idea. So now we're going to add another class named pet flag for adoption integration event handler. And of course, this is the event handler. That's why it's going to be a background service because we want this to be running all the time. So now I'm going to add a constructor because I want to inject an iConfiguration object and also an iLogger of pet flag for adoption integration event handler. And let's put the logger in a field. And now we need to add a service bus client and also a service bus processor. And here in the constructor, we're going to instantiate the client. So for instance, we're going to new service bus client, and we're going to use this overload that takes the connection string. So that's why we're going to use something like service bus colon connection string. This means that we need the service bus client in the app settings JSON file or the user secrets or what have you. Actually, you can use any configuration provider you want. And now let's instantiate the processor, but this time we're going to use the create processor method, and we're going to use this overload that takes the topic name and the subscription name. So for instance, let's say service bus topic name, and also configuration service bus subscription name, just like that. And now we need to handle the processor events. In other words, we're going to handle process message async and also process error async, just like that. For the error method, we're going to use the logger. We're going to log, let's say, log error, and we're going to use the exception object, and we're going to return task completed task. And let's rename this to args. I think it's better. Args. Just like that. And now in the execute async method, we're going to start listening for events. So that's why we're going to invoke start processing async. And let's pass this stopping token just like that. And we're going to mark this as async because we need to await this call. And we need to override the stop async method because we need a way to stop processing for events. Processor stop processing, and we're going to pass cancellation token as well. Next, we need to implement process message async. Here, we're going to read the body of the message body to string, and let's rename this to args as well. And now we're going to deserialize that string to an object. So we're going to use Newton's of JSON for that. Let's say the event equals JSON convert dot deserialize, and we're going to pass pet flag for adoption integration event. And of course, we need to pass the body. And we need to await for args complete message async, and we're going to pass args.message. And here we're going to use the logger as well, but this time for logging that information, let's say the body itself. Okay, so now we need to modify the startup class. So let's open up that because we need to register the background service. So that's why we're going to invoke add hosted service of pet flag for adoption integration event handler, just like that. And now we need to modify the configuration. So here we're going to create the service bus element. And actually I have the code already here, and I'm going to paste it. As you can see, this is specifying the topic name and the subscription name, as well as the connection string. Finally, we need to be sure that this solution will start both pet and rescue. So you can do that if you right-click on the solution and then go to set startup projects. And here you choose multiple startup projects and be sure to select Pet API and Rescue API. So let's test this. So now both microservices are running. We have here the Pet microservice Swagger UI. And let's test this by clicking on the Pet flag for adoption endpoint, try it out. And before I click on execute, let's go back to Visual Studio so we can insert a breakpoint. So here in Visual Studio, let's go back to the event handler and let's put a breakpoint right here. And let's go back to Swagger. So now let's click on execute. And of course, we receive the message. Excellent. In the next video, we'll store the integration event data in the database by using Entity Framework Core. At this moment, we're receiving messages from the subscription set in Azure Service Bus. Now we'll store the event data in the rescue database. Because of that, we're going to create a new table named Rescued Animals Metadata that stores the pet information that we're receiving. So let's jump right in. So here in Visual Studio, I'm going to open this RescueDB context class because we're going to add another property of type dbset of pet flagged for adoption integration event, which is the type that we're receiving from Azure Service Bus. And this is gonna be rescued animals metadata. Excellent. So now let's open up this pet flagged for adoption integration event handler class because I want to add the rescued animals metadata. And also, I'm going to store the state of the rescued animal that belongs to this rescue domain model. This is important to remind you that you don't have to use the repository pattern always. Also, I didn't want to modify the domain model. So the first thing that I'm going to do in this class is to inject a new iService scope factory object. Put this inside a field right here. And in the process message async method, let's get rid of this logging information. We don't need it anymore. And here I'm going to create a new scope by using the service scope factory. So I'm going to execute this create the scope, and let's put this in a new variable. And now I'm going to obtain the iRescue repository object. So I'm going to use the scope service provider get required service of iRescue repository. So we have the repository variable, and now I'm going to obtain the rescue DB context as well. So DB context, scope, service provider, get required service of rescue DB context, just like that. And now I'm going to use the rescued animals metadata property that we created. And now I'm going to execute add, and I'm going to store the event that is right here. And after that, I'm going to create a new rescued animal object of rescued animal. This is from the domain model of this microservice. And I'm going to use rescued animal ID, create, and let's pass the event ID. And now I'm going to store this object by using the iRescue repository object. So let's type repo add rescued animal async, and I'm going to pass this rescued animal, and just like that. Excellent. Please take into account that even though we're using Entity Framework Core, we're not using the migrations logic. So we need to drop the rescue database before testing this implementation. So let's open the SQL Server Management Studio. And here I'm going to right click on the rescue database, and let's use this delete option, and we're done. Let's go back to Visual Studio so we can test the implementation that we have done. We need to start the rescue microservice. So let's right click here in the solution, and we're going to add the rescue API project as a start action. I've already done that, so we're ready to test this. Here we are again in the Swagger UI, and let's click on this flag for adoption endpoint, execute. And let's go back to SQL Server Management Studio so we can see if the database was created again and if we have data. So let's right click here, refresh. As you can see, we have the rescue database again, but this time we have the rescued animals metadata. And let's select top 1000 rows. And as you can see, we have this pet information in the rescued animals metadata. And also we have the rescued animal state stored in this rescued animals table. You've already seen a bit of event-driven architecture topics, and it's time for you to roll up your sleeves. The time has come for a challenge. Take into account that this is not a short challenge. The goal is for you to get real hands-on practice implementing loosely coupled microservices by using events and Azure Service Bus. For this reason, it'll take you something between 45 and 60 minutes to complete. If you'd like to skip this challenge, you can join me in the next chapter. Otherwise, let's explain the details. In this challenge, you'll communicate from the pet microservice to the hospital microservice. This time, you're going to use the pet transfer to hospital domain event from the pet domain model. Also, you're going to store the event data in the patient's metadata table of the hospital database. You can see a list of classes that you have to create or tasks that you have to perform to complete this challenge successfully. When you're done, join me in the next video and I walk you through how I approach this. Let's see how we can solve the challenge. First off, we're going to add the pet transfer to hospital integration event class in the pet API project. So right here in the integration events folder, I'm going to add a new class named pet transfer to hospital integration event. And this is going to implement an integration event. And it will have the same properties as before. So I'm going to paste them right here and we're good to go. Now we need to handle the pet transfer to hospital domain event inside the pet application service class. Actually, it's very similar to this code, so I'm going to copy this and paste it. But instead of pet flag for adoption, we're going to use pet transfer to hospital. And of course, this object has to change to pet transfer to hospital integration event. Of course, we need to change the configuration values as well. So I'm going to change these to transfer. And let's modify app settings JSON because we need another sub element named transfer that I actually have right here in the notepad. The first thing that I want to do here is to create a new folder named integration events. And here I'm going to add another class, pet transfer to hospital integration event, just like before. But this time I don't need to implement the integration event interface. But we need the properties, so I'm going to copy them again. And we're going to have the same properties as before. Now we need to create a new class here named pet transfer to hospital integration event handler. And please remember that this kind of handlers have to inherit from background service. So background service, and let's implement this. And I'm going to add a new constructor. And we need to inject the iConfiguration object. Also, a new iService scope factory. And also an iLogger of pet transfer to hospital integration event handler. And let's put this inside a field, this other as well. And now we're ready to create a new service bus client object. So let's create it right here as a field, service bus client. Of course, I need to install the Azure Messaging Service Bus package. I'm going to use this tool and I'm going to name this as client. And now let's instantiate this service bus client. And I need to pass the connection string. So configuration of service bus connection string. Speaking of which, we need this configuration. So right here in the app settings JSON file, I'm going to add the configuration that I already have here. So I'm going to paste it right here. Excellent. So we have the connection string, also the topic name and the subscription name. Let's go back to the file because we need to create a new processor. So private read-only service bus processor. Processor comes from create processor, and we need to specify the topic name and the subscription name. So I can use service bus, topic name, and configuration of service bus subscription name, just like that. So we need to handle the process message async event and also the process error async event. And now we're ready to implement the code here in the process message async event handler. But before we do that, we need to modify the hospital DB context file because we need to add an additional property of type dbset of pet transfer to hospital integration event. And the name for this property will be patient's metadata. Excellent. So now let's go back to the handler. And the first thing that we need to do is to deserialize the event. But instead of writing the code, I'm going to paste it. I have it right here in the notepad. And we're going to use this JSON convert class that comes from the Newton_JSON package. And finally, let's solve this using, and we're good to go. As you can see, we're using the hospital DB context to save the patient data inside the patient's metadata table. Okay, finally, we're going to execute the processor right here. And of course, we need to stop it as well. Processor, stop processing. Let's wait for that. And of course, we need to handle this. So for example, log error, arg, exception to string or something like that. And let's just return this task completed task object. Okay, so before we test this microservice, we need to modify the startup class because we need to add the hosted service, which is the pet transferred to hospital integration event handler. That's the name of this hosted service. And we're good to go and test this microservice. So please remember that you have to configure your solution so you can start the rescue, the pet, and the hospital microservices. Okay, so let's start. Before we execute the pet transfer to hospital domain event, let's see if the database was created already. So here in SQL Server Management Studio, we can see that the patient's metadata table was created successfully. Okay, let's go back to the Swagger UI. So here in the pet microservice, I'm going to click on the transfer to hospital endpoint and let's execute. And let's go back to SQL Server Management Studio so we can see if the data is present. And as you can see, we're receiving the data successfully. Okay, that was a lot of code. Follow me in the next chapter where we'll see the CQRS pattern. In this video, we'll talk about the CQRS pattern. CQRS stands for Command and Query Responsibility Segregation. The idea behind this pattern is to have completely separate models for reading and writing data. Be aware that I said model, not necessarily different databases. This idea is indeed a shift away from the well-known single data model scenario in CRUD systems where we do both read and write operations. The reason why this pattern is quite useful is because no database technology is optimized to be great at both reads and writes. For example, have you ever tried to implement graph structures such as nodes and edges in a relational database? I surely have, and that didn't go well. In CQRS, commands describe actions that change the data. As a result, they modify the state of the system, so they have side effects. On the other hand, queries return data and don't modify the state of the system. For that reason, they don't have any side effects and are idempotent. In other words, it doesn't matter how many times you execute a query, the result will be the same. Let's dive deeper into this pattern. Commands should be validated before they are applied to the model. For example, in the Wisdom Pet Medicine solution, we receive the commands as part of the HTTP request payload. Then we handle the command in the application service, which in turn invokes the domain model logic to attempt to apply the given command, and finally we store the state back to the database. Queries are completely separate functionality and they don't depend on domain knowledge. They're just a way to get the data out from the database. For this reason, we could use different technology stacks if we want to. For example, in the Wisdom Pet Medicine solution, we'll use Dapper, a lightweight ORM framework that allows us to execute any query without hassle. Of course, we don't even need an ORM for that matter. The point here is that with CQRS, you can escape from overly complex single models with poor performance and cumbersome design. As you can see in this diagram, both commands and queries are using a single database. Take into account that queries could return DTOs or dynamically created structures. In this course, we're going to use the latter. Now, we could implement the command and query parts as separate microservices, or we could implement them in the same microservice. That decision will depend on the particular business requirements that you have. You can achieve greater isolation if you physically separate the read data from the write data. Also, you could take advantage of having different data store technologies. In that sense, you could have an optimized data store for queries. The challenge in this scenario is, how can we synchronize the data from the write model to the read model? Well, there are different ways to do that, but generally speaking, you need some kind of event or message. Another option could be that the command is responsible for writing in both databases. However, I think that could negatively impact the performance and scalability. In this course, we'll use the Azure Cosmos DB change feed when dealing with CQRS and two separate databases. As I've already mentioned, you could implement each part in a separate microservice, or you could implement them as a single one. Finally, let's discuss some of the benefits of CQRS. Having the ability to use different data models for writes and reads is clearly a significant benefit. Each one could take advantage of the underlying data store technology to optimize its model. Scalability is enhanced because we could scale each microservice independently. In most systems, the number of read operations exceeds the number of write operations. Finally, the code is more maintainable because all the logic is implemented in the write model, and we can project any kind of data structure from the read model. In this video, we'll deal with the command part of the CQRS pattern. First, we'll add a new value object named adopter phone number. Then we're going to create a new property in the adopter entity named phone number of type adopter phone number. Since we don't want to allow external domain models or systems to modify the state of an entity object directly, we're going to expose a public method named setPhoneNumber. In addition to that, we're going to modify the state validation logic of the adopter entity to prevent invalid phone numbers, at least in terms of string length. Next, we'll create a new class named setAdopterPhoneNumber command in the Rescue API project. After that, we'll modify the adopter application service class to add a new method for handling the setAdopterPhoneNumber command. The adopter controller will initially receive the command as part of the HTTP request, which in turn uses the newer handler that we'll implement. Finally, we'll modify the RescueDB context to tell Entity Framework Core to flatten the structure of the adopter entity when persisting it. Okay, let's get started. So here in Visual Studio, I'm going to add a new class inside the value objects folder, and this is going to be adopter phone number. And we're going to use record instead of class because this is a nice addition to the C# language that allows us to compare objects based on their values. I'm going to create a new constructor that takes the phone number. And this is going to be internal because I just want to create these adopter phone number objects inside the domain model. And of course, we need another way to create this kind of objects outside the domain model. So I'm going to create another method here that takes the phone number. And this returns a new adopter phone number object. Excellent. We need also some kind of property to expose the value. But this time, I'm going to make this property as init. So it becomes immutable after initializing. So I can do that. And finally, I want to create a new validation method that I already have here. So as you can see, I'm validating that the phone number is not null and the length is less or equals to 15. And I'm going to invoke this validate method right here. And we're good to go. Now we need to modify the adopter entity because I want to expose the adopter phone number type. This is going to be phone number and private set because I don't want to modify these properties or the state of the entity outside the domain model. Excellent. Next, we're going to modify this validate state for adoption method because I want to validate if the phone number equals null. Then I'm going to throw a new invalid adopter state exception. And let's say phone number is missing. And we're good to go. Now let's open the Rescue API project because we need to create the command right here. I'm going to create the set adopter phone number command. And this will expose a couple of properties. The first one is the adopter ID. The second one is the phone number itself. Let's name it phone number, just like that. So let's modify the adopter application service class because we need to receive the command object right here. I'm going to copy this and I'm going to replace this command with set adopter phone number command. Of course, we need to obtain the state of the adopter. Then we're going to use the set adopter phone number that actually we didn't implement. So let's go back to the adopter entity and let's add a new public void set phone number that takes adopter phone number, and we're going to set phone number equals phone number, and we can go back here. Let's rename this because this is ID instead of adopter ID, and we can use this set phone number method that takes the phone number value. Of course, we need phone number dot create command phone number, and we're persisting the state back to the database. So as you can see, it's very easy to handle this command. And of course, we need another method in the controller. Let's go to the controller, and I'm going to copy this. Let's name this segment as phone number, and let's use HTTP put, and this takes set adopter phone number command, and basically that's it. Let's move this to this position after the request adoption command, and we're good to go. Actually, we can now test this, but before we do that, we need to modify the rescue DB context right here because we need to flatten the structure. We need to tell Entity Framework Core that the phone number is part of the same table. So I'm going to copy this and I'm going to use phone number. And of course, we need to delete the rescue database because otherwise, this is not going to recreate the database. Remember that we're not using EF Core migrations. So let's go to SQL Server Management Studio. And right here, I'm going to drop this database rescue. Okay, close existing connections. And let's go back to Visual Studio. And now we're ready to test this. So let's start a new debugging session. It looks like it has some problems with my ports. So let's change the port right here. I'm going to change it to this other port. Let's try it again. As you can see, this is running, so let's go back to SQL Server Management Studio to see if the database was created. So here's the database. And of course, we need to create a new adapter. So let's go back to the Swagger UI. So here, I'm going to create a new adapter. Let's click on Execute. Actually, the values don't matter right now. I'm going to click on Execute, and let's go back to SQL Server. And right here, I'm going to right-click and select top 1000 rows. As you can see, we have the new adapter right here. So now we're ready to modify the phone number, which is null in this moment. So let's go back to Swagger. And right here, I'm going to select this other endpoint. Try it out. And let's say plus 1, 2, 3, 4, 5, 6, 7, 8, 9, or something like that. Execute. Let's go back to SQL Server. And let's click again on Execute. And as you can see, the phone number has changed. Good job! Now we're ready to implement the query part. Follow me in the next video. We've gone through the command part of the CQRS pattern already. Now it's time to implement the query part. Let's see how we can do that. In this video, we'll add a new rescue query microservice. The reason why this is a separate API is because after the event storming session with Wisdom Pet Medicine's domain experts, we detected that external systems would heavily use this API. Therefore, we could scale this microservice independently. We could also modify it independently if that were necessary. We'll use Dapper to query the database and project a different view model freely. Remember that these kind of queries, most of the time, are meant to be used in user interfaces, reports, and so on. For this reason, it's nice to have different models for both commands and queries. Okay, let's move on. So here in Visual Studio, I'm going to create a new project inside the rescue folder. And let's use this ASP.NET Core Web Application template. Let's put this inside the source folder, and we're going to name this project as Wisdom Pet Medicine.rescuequery.api. And let's click on Create. Excellent. Now, the first thing that we need to do is to delete this weather forecast class because that comes from the template, but actually we're not going to use that class. And let's rename this weather forecast controller class to rescue query controller. Rescue query controller. Excellent. And let's get rid of everything. Now we need to add a reference to Dapper. So let's manage the NuGet packages and let's search for Dapper. Let's install that. And also we need the Microsoft Data SQL Client package because we're going to use the SQL connection object. Done. Excellent. Let's go back to the rescue query controller class. And there we're going to add a new constructor and we're going to inject the iConfiguration object. Let's put that inside a field. And now we're ready to implement the endpoint. For instance, I'm going to use task of iActionResult, and let's name this get or something like that. And we're going to use the HTTP get attribute. Excellent. Now we're ready to write the query that we want to execute. Since we're using Dapper, we're free to write any kind of query we need. I don't want you to see me typing, so I have the query already, and I'm going to paste it. As you can see, I'm using some T-SQL sentences such as case to project different columns. And also, as you can see, we're using the rescued animals metadata, the rescued animals table, and also the adopters table. So let's solve this namespace and also the query async namespace, and we're good to go. Before we test this microservice, we need the connection string. So let's edit this app settings JSON, and we need the connection strings subsection, and we're going to type the connection string. Actually, we have that already in place. So let's open the app settings JSON file from the Rescue API project. Let's copy this. Let's go back and paste it right here. Done. Finally, we need to be sure that this new project gets executed. So let's right-click here in the solution, set startup projects, and here, the Rescue Query API, we're going to set it as start. Done. Let's click on the start debugging session, and let's go to the Swagger UI. So here, I'm going to click on the Get button, try it out, execute, and this is returning 200. However, we're not receiving any results. That's because I deleted the database. So let's go to the Swagger UI of the pet microservice. Now we're going to flag the pet for adoption. Done. And let's go to the Swagger UI of the rescue microservice. Here, I'm going to request to adopt that pet. And now we can go back to the Rescue Query API. Let's try this again. Try it out, execute. And now we're receiving the projected data that comes from this rescued animals metadata, rescued animals, and adopters. Now it's time for a challenge. The goal is for you to get real hands-on practice implementing the CQRS pattern. If you'd like to skip this challenge, you can join me in the next chapter. In this challenge, you'll create a new command named setDateOfBirth command. You have to modify the pet application service class to handle the new command. You also have to modify the pet controller class to implement a new endpoint capable of receiving a setDateOfBirth command. Finally, you have to implement a new pet query controller that has a single get endpoint. The endpoint has to return a projected view model based on the pets table. Again, use Dapper for this functionality. You can see a list of classes that you have to create or tasks that you have to perform to complete this challenge successfully. When you're done, join me in the next video and I'll walk you through how I approach this. Okay, let me walk you through how I solved the challenge. The first thing that we're going to do is to create a new class here in the commands folder. Let's name it setDateOfBirth command. And this class has two properties. The first one is for the pet ID. Let's name it ID. And the second one is for the date of birth itself. So this is going to be a datetime, date of birth, and we're done. Now we need to modify the pet application service class because we need to handle the command somewhere. And this is the place. So I'm going to copy this method and let's change this type to setDateOfBirth command. Of course, we need to restore this state from the repository. So that's okay. And instead of setColor, we're going to execute setDateOfBirth. And let's create a new petDateOfBirth object. So petDateOfBirth, create, and we're going to pass the date of birth that we're receiving from the command. And now we need to modify the pet controller class because this is the place where we're going to expose the endpoint. So for instance, I'm going to copy this. Of course, we need to change the command type to setDateOfBirth command, change the route to date of birth, And that's it. We're handling the command already here. Now I need to add Dapper to the project. So we already have Dapper somewhere right here in the rescue query API. So I'm going to copy this package reference element and I'm going to paste it right here. And we're ready to create a new class named pet query controller. Of course, we need to inherit from controller base. And also we need to use the route attribute and the API controller attribute as well. Now we're ready to add the constructor because we need to inject the iConfiguration object. We're going to put that inside a field. And now let's expose a new endpoint facing task of iActionResult. Let's name it get. Of course, this is a HTTP get endpoint. And here we're going to write the query. I already have the query, so I'm going to copy that and paste it right here. As you can see, I'm using the pets table and I'm projecting the sex of pet value column to a string value. So let's solve this namespace and this other as well. And we're ready to test this microservice. So here they are. And let's open this Swagger UI webpage. And right here, we can find the pet query endpoint. Let's try it out, execute. And as you can see, we're receiving the data. This data was projected from the pet table. Another important thing to notice is that we don't have to use strongly typed DTO classes. I'm just using a dynamic object because at the end of the day, that's going to be serialized to JSON. In this video, we'll describe the event sourcing pattern, its principles and challenges, and also we'll highlight some of the benefits we get by adopting it in our solutions. Before I start describing the event sourcing pattern, let's see first how it compares to the traditional CRUD approach. Let's suppose that we have modeled an aggregate by using DDD, for example, the patient aggregate in the Wisdom Pet Medicine system. We have a database with one or more tables that persist the aggregate state in this traditional approach. The application service invokes the aggregate methods to change its state. For example, we invoke the setWeight method and pass a value in kilograms for the patient, say 23.5 kilograms. The method validates the input and changes the inner state of the object. After that, we commit the state to the database. At this point, the entire state was stored. We could use an ORM or not, although it really doesn't matter. Now, what would happen if we invoke the setWeight method again, but this time we pass another value, say 21 kilograms? Again, the domain model object, in other words, the aggregate, changes its state, completely overriding the previous one. If we decided to commit the state, then it would replace the state in the database. In this fashion, we could continue invoking methods to change the state. In this case, the admit method, which in turn changes the status property. Again, if we committed the state, then it would entirely override the state in the database. And what about this other discharge method? We could invoke it, let the object change its state, and then persist it to the database. You get the idea. The thing with the traditional CRUD approach is that we always commit a new state and the previous one gets overridden. This approach has a number of pros. First, it's very easy to grasp. Second, it's quite prevalent among software developers and architects. Third, it might be enough for most applications and solutions. Of course, it has some cons too. The first one, as demonstrated in the previous diagrams, is that you can know how you got where you are since you're replacing the state each time. Second, there's no history of the changes that you applied. And third, there's no such thing as going back in time to know what the state was at a given date. With event sourcing, things are quite different because what we do is to persist the events that triggered the state transition in an append-only storage. In this pattern, the events are the source of truth for the state. To better understand this concept, let's see the following diagram. Let's see we have the same patient aggregate that has the set wait, admit, and discharge methods, and also the database and the application service. If we invoke the setWait method, it creates and applies a new event. The event itself is triggering the state transition. Now, we don't persist the state of the aggregate. Instead, we commit the sequence of events that triggered the state transition. In this case, the wait updated event. Following the previous scenario, we could invoke the setWait method again with a different value, which in turn creates and applies another wait updated event that triggers another state transition, and then we store the event with its related metadata. As you can see, we append the event in the database or event store. We never ever delete or modify events. Again, we invoke the admit method. It creates and applies the admitted event, which triggers the state transition. And finally, the event is appended in the event store. Let's conclude by invoking the discharge method, which creates and applies the discharged event. And after we commit, the event is appended in the event store. As I've already mentioned, the events are the source of truth for the state. That's precisely why it's crucial to store the sequence of events just as they were created. I've been talking about saving the events that led to the current state over time, but what about loading the events to rehydrate the state? Well, in event sourcing, the state of an aggregate is reconstructed by replaying the events. You should have some kind of API that reads the events from the event store, so you can replay them in the same order as they were created over time to reconstruct the state. For example, in this diagram, we're reading the events and then we're invoking the load method in the aggregate object in order to apply each event. At the end of this process, we'll have an aggregate object with the latest state. We could also have a numeric version property that tracks how many events have been applied in that particular object. That state could be persisted in a different database for reading purposes. In other words, you derive a read model from your event store since the events are not meant to be queried directly. Event sourcing has some fantastic benefits. However, you should have a real business reason to use it. Be aware of its pros and cons before attempting to implement it in your own projects. Take into account that event sourcing could benefit from CQRS, and most of the time it's truly needed because of the differences between the write and read models. But the other way around is not true. In fact, event sourcing and CQRS are two completely different patterns and techniques. Remember that the write model is append only. For this reason, the events that we store are forever immutable. On the other hand, you could find yourself needing to fix an error in the events. In that case, you should create compensating events. Finally, keep in mind that you could, and frequently you do, have more than one read model. For instance, you could derive one for your reporting platform, another one for your user interfaces, and another one for integration purposes. Last but not least, let's talk about some of the challenges that you could face when implementing event-sourced solutions. The first one that I want to mention is the mindset you should have when adopting this pattern. As demonstrated, it's very different from a regular CRUD system, so there's a learning curve. You should take into consideration that your read models will be eventually consistent. However, that's something you should always consider in a microservices solution anyway. Your events could evolve into different structures, so you should have a good versioning strategy in place for them. For example, in the Wisdom Pet Medicine solution, we store the assembly qualified name where the event is implemented. So it's there right in the code as an example for you to explore. Also consider that an aggregate could have dozens, hundreds, or even thousands of events. In that sense, you could consider creating state snapshots based on your sequence of events, so you only look at the events that have been saved since then. Okay, we have gone through a lot in this video, and it's time to move on. In this video, we're going to provision the Azure Cosmos DB account that will work as the event store, And we're going to start implementing the patient aggregate store class. So here we are in the Azure portal, right here in the create a resource page. I'm going to select Azure Cosmos DB. And for this training course, we're going to use the core SQL API. And of course, you have to set the resource group, the account name, and also the capacity mode. I already have the Azure Cosmos DB account created. And as you can see, we already have the Wisdom Pet Medicine database with the patients container. So we're ready to go to Visual Studio. Right here in Visual Studio, I'm going to right-click on the hospital folder because we need to create a new class library. Let's put that inside the source folder. And this project will be Wisdom Pet Medicine .hospital.infrastructure, just like that. And we need to add a reference to Microsoft.azure.cosmos and also Microsoft Extensions configuration abstractions. I happen to have that already, but before I paste it, let's change this to .NET 5 and let's paste the references. Excellent. Now we're going to add the patient aggregate store class. I'm going to reuse this class one, so let's rename it patient aggregate store. And of course, we need to add a reference to the hospital domain project because we're going to implement the IE patient aggregate store interface. As you can see, it has the load async and save async methods. Okay, so we're going to inject the iConfiguration object in the constructor because we need to read the configuration from somewhere. And in this training course, I'm using the app settings JSON file. So I'm going to paste the configuration that I already have here in the notepad. So let's copy this and paste it right here. As you can see, I'm creating this Cosmos DB section that has the connection string, database ID, and container ID. Of course, I copied the connection string from the Azure portal beforehand. And the database ID is Wisdom Pet Medicine, and container ID is the patient's container that we created inside the database. Excellent. So let's go back here and let's read those values. Connection string, configuration, which is inside Cosmos DB connection string, and database ID, Cosmos DB database ID, and finally the container ID, Cosmos DB container ID. Excellent. Now we're going to create a couple of fields from the Cosmos DB API. So for instance, I'm going to use the Cosmos client. That's the name of the client that we're going to use to communicate to Azure Cosmos DB. And we also need the container, patient container. That's the name of this field. So we're going to create a new instance of Cosmos client, and we're going to pass the connection string and also the client options that we are going to instantiate right here, client options, Cosmos client options. And this is because I want to set the property naming policy as camel case. So for instance, serializer options equals Cosmos serializations options, and then property naming policy, and we're going to use camel case, just like that. So I'm ready to use this client options object. And finally, patient container will be the result of calling get container from the Cosmos client. And we're going to pass database ID and also the container ID that we already have here. Perfect. So now we're ready to create and store the first events. Follow me in the next video. We need a new class to represent the events that we want to store in Azure Cosmos DB. So in this video, we're going to create the Cosmos event data class right here in infrastructure, Cosmos event data. And of course, we need some properties that I already have here to expedite this process. The first one, ID, is the ID itself. is the document unique identifier in Cosmos DB. Aggregate ID will be the name of the aggregate, in this case patient, and we're going to concatenate the patient identifier. So we need this because, as you might remember, we're using the property as the partition key in the container. Then the event name, the data, that is the original event, serialized as a string. Finally, the assembly qualified name that we're going to use to store the fully qualified name of the source assembly where the event is implemented. This is important when you want to evolve your events, but you still need to rehydrate the previous events. In this course, I'm going to use a single version of the event, but you could explore the idea behind this technique. Okay, so here in the patient aggregate store, we're going to implement the save async method. So I'm going to paste the code because I don't want you to see me typing. And let's explain this after we solve the different usings. Excellent. So the first thing is to validate if the patient object is not null. And then for each event that we obtain from the getChanges method, we're projecting a new Cosmos event data object. For the ID, we're using a new identifier. For the aggregate ID, we're concatenating the patient keyword and the ID itself. The event name is the name of the type of the event. And data is, of course, the entire event serialized as a string. And finally, the assembly qualified name is the assembly qualified name that we're obtaining from the getType method. As you can see, I'm serializing this string. Of course, we could use the assembly qualified name value as is, but it's okay. And finally, we're projecting this to an IEnumerable of Cosmos event data. At the end of the day, this is an IEnumerable of Cosmos event data. So we're validating if there are no changes. And finally, for each one of those changes, we're invoking the create item async from the container object from the Cosmos DB NuGet package. Okay, so now we're ready to add a reference here in the hospital API project. I'm going to add a reference to the hospital infrastructure project. And here in the integration events folder, I'm going to open up this pet transfer to hospital integration event handler because we're going to inject the iPatient aggregate store. And let's put it in a field. And here in the process message async event handler, we're going to do the following. We're going to create a new patient ID object that is a value object. And we're going to use the event.id. And now we're going to create a new domain object of type patient. And we're going to use this constructor. This is very important because this is the place where the patient created domain event is applied. So that's why we're using this constructor. And finally, we're going to await for the save async method to finish. So we're using this pet transfer to hospital integration event handler object to create the first patient in the event store. In other words, we're storing the patient created event when we receive this pet transfer hospital to integration event. So now we're ready to open up the startup class because we need to register the patient aggregate store. We're going to use a singleton, iPatient aggregate store, patient aggregate store. That comes from the infrastructure project. And now we're ready to test this. We're going to save all the projects and let's be sure that we have no errors. And finally, we're going to execute all the microservices. Okay, so in this pet microservice Swagger UI, I'm going to click on transfer to hospital, try it out, execute. And let's go to the Azure portal. So here in the Azure portal, I'm going to open up the Data Explorer, and then we're going to expand Wisdom Pet Medicine, Patients, Items, and as you can see, we have the patient-created event. We can see the data. We can see the assembly qualified name of this event. And of course, the aggregate ID, which is the patient keyword concatenated with the patient ID. Great. Now we're ready to implement the code to load events. In this video, we're going to load events from the event store. So let's open up the patient aggregate store class. And here in the load async method, we're going to implement the code for loading the events. First, we need to, let's rename this to patient ID. So let's validate if patient ID is null, in which case let's throw a new exception of type argument null exception, and let's say name of patient ID. And now we need to specify the aggregate ID. As you might remember, this is the patient name, and we're going to concatenate the patient ID itself. So patient ID dot value. So now we need the query to obtain all the events that are related to the specific aggregate ID. So SQL query text or something like that. And let's say select star from C where, let's say, C aggregate ID equals, and we're going to use again the aggregate ID. So as you can see, I'm using the SQL API to obtain all the items from Azure Cosmos DB, which is pretty cool. And now let's create a new object of type query definition, because we're going to pass the query itself right here. And now we're going to use the patient container, and we're going to use this get item query iterator. So for instance, we're going to use that and the generic option. So we're going to obtain Cosmos event data, and let's pass the query definition. And we're going to put that inside a query result set iterator or something like that. And now we're ready to obtain all the events. First, let's create a new list of Cosmos event data. And let's write the following. While query result set iterator has more results, let's create this current result set variable, because I want to wait for the query result set iterator read next async. And now we're obtaining the item right here. So if that has some data, let's iterate by using Cosmos event data in current result set. So we're going to add that item in the list of type Cosmos event data that we have here, right? So now we're going to create the following variable, domain events, and we're going to project all the events that we obtain from Azure Cosmos DB. We're going to do the following. First, we need to obtain the assembly qualified name. So assembly qualified name, and we're going to use JSON convert because we need to deserialize the following property. As you might remember, this is the place where we store the fully qualified name of the assembly where the event is implemented. And now we can use this assembly qualified name because we need to dynamically create an instance of that event. So for example, event type, I'm going to use the type class, and I'm going to use get type, and I'm going to pass the assembly qualified name because we're going to deserialize the data, this data that is right here, as of type event type. So var data equals JSON convert. Let's use deserialize. And let's pass data, and I'm going to pass the type right here. In other words, I'm going to pass this event type, and we have the event right here. So let's return that event as iDomain event. And now we're going to do the following. Let's scroll down a little bit. Let's create a new aggregate. In other words, I'm going to create an instance of patient, and I'm going to use this constructor. As you can see, I'm using this empty constructor because I don't want to apply the patient created event in this moment. However, I want to pass all the events so the aggregate can apply each event to that specific aggregate. So for instance, I'm going to execute load, and I'm going to pass domain events, which is this variable that we have here, that is an IEnumerable of type iDomain event. And finally, let's return the aggregate. So now let's inject the iPatient aggregate store in the hospital application service class. So let's open up this API project. And here, let's inject iPatient aggregate store. As you can see, the field is already in place. We just need this line of code. And we're ready to test this microservice. So let's save this and let's execute all the microservices. Here in the patient Swagger UI, I'm going to execute the patient weight endpoint because we need to set the weight for the patient. Let's say 25, execute. This is returning 200. And let's execute this other endpoint for setting the blood type. So try it out. Let's change this to a real blood type of dogs, DEA-1.1. This is a real type. Okay, let's execute 200. And finally, I'm going to admit the patient. Try it out, execute. So as you can see, we created 3 events. So let's go to the Azure portal. And here I'm going to expand the patient's container items. And as you can see, we have the patient created event that was created when we transferred the patient from the pet microservice. And this is the patient weight updated event. Also the patient blood type updated. And finally, the patient admitted. Well, this is working as expected. So now we need a way to project and sort the current state of a patient. Let's do that in the following challenge. Now it's time for a challenge. Take into account that this isn't a short challenge. The goal is for you to get real hands-on practice implementing some of the event sourcing principles. Specifically, we're going to implement code for projecting the current state of a patient aggregate to a SQL Server database. This challenge will likely take you something between 45 and 60 minutes to complete. Of course, if you'd like to skip this challenge, you can join me in the next chapter. The code in this challenge is critical because with event sourcing, the event store is not meant to be queried directly. Instead, we're going to combine the CQRS pattern and event sourcing. The current Azure Cosmos DB database is a right side of the CQRS pattern. We're going to take advantage of its change feed to automatically invoke a Cosmos DB trigger inside an Azure function. The trigger will get the written items, in other words, the events, and then it's going to apply all the events in the patient aggregate to obtain the current state. After that, we're going to update the patient's table in the SQL Server database with the latest aggregate state. For this, we're going to use Dapper. Finally, we're going to implement a new patient query controller class in the hospital API project that queries the SQL Server database directly. Again, we're going to use Dapper. The Azure function should be named wisdompetmedicine.hospital.projector, and it has to reference both hospital infrastructure and hospital domain to be able to work as expected. We need to add some NuGet package references. Be careful to reference the ones that begin with Microsoft Azure Functions Worker since those are the latest versions of the triggers and bindings. The function name should be patient projector, and there we're going to inject both iConfiguration and iPatient aggregate store. iConfiguration for reading the connection string required for connecting to the SQL Server database, and iPatient aggregate store because we need to get the events from a given aggregate. As I've already mentioned, we're going to use Dapper as the ORM in this challenge. So let's go ahead and get started. Okay, let's see how we can solve this challenge. The first thing that I want to do is to create the Azure function. So let's name it wisdompetmedicine.hospital.projector, and we're going to put the code inside the source folder. Here, we're going to use the Cosmos DB trigger because that's exactly what's going to happen. We're going to connect to the change feed of Azure Cosmos DB. Here, I'm using .NET 5 isolated because that's the latest version of Azure Functions at the time of this recording. For the connection string setting name, I'm going to use Cosmos DB connection string. And for the database name, as you might recall, is Wisdom Pet Medicine, and the collection name is Patients. Now, we need to add a reference to both domain and infrastructure. And also we need additional NuGet packages here. So to accelerate this process, I have the code already and I'm going to paste it. As you can see, we're using Dapper and Microsoft Data SQL Client because we're going to use SQL Server to save the projected state. Okay, let's close this, and we need to do a lot of things here in the function. The first thing is to rename it to Patients Projector, just like that. And also the friendly name will be Patients Projector. And we're going to remove the static keyword because we're going to use a constructor for injecting an iConfiguration and also an iPatient aggregate store that, as you might remember, is implemented inside the domain repository's namespace. Just like that, let's put it in a field and also the configuration. Just like that. Excellent. We also have the database name, the collection name, the connection string setting. We need the create list collection if not exists, because we need to be sure that the lists collection is created beforehand. Now, let's get rid of this myDocument class. We're not going to use that. Instead, we're going to use Cosmos event data that is implemented inside the infrastructure namespace. And actually, let's replace this static void with async task. And we're ready to implement the function code. We need to read the input. In other words, we need to obtain the items that are being written in the Azure Cosmos DB. So I happen to have the code already here. In the interest of time, I'm going to paste the code. And let's solve the Data SQL Client namespace, also the value objects namespace, and system.link. The most important part of this code is the following. As you can see, we're reading the input, and then we're obtaining the patient ID, and then we're rehydrating the state for the patient aggregate by using the load async method that is implemented in the patient aggregate store object. As you can see, some things are missing because we need an additional class named SQL Connection Extensions that we're going to add right here. Let's add the class SQL Connection Extensions, and I'm going to paste the code. As you can see, I'm using Dapper, and the ensure patients table is creating the patients table itself, and the insert patient method is inserting a patient in that table. Okay, excellent. So I think we're ready to go to the program class because we need to specify that we're going to use a patient aggregate store as the concrete implementation of iPatient aggregate store. So let's invoke configure services and let's pass this lambda expression. And here I'm going to use add singleton, which is inside the Microsoft extensions dependency injection namespace. And for this iPatient aggregate store, we're going to use patient aggregate store without the capital I, just like that. Excellent. Finally, we need to configure this Azure function. So I need the connection string for the SQL database, and also I need the connection string for the Cosmos DB database. So I already have the code here, and I'm going to paste it right here. As you can see, this is the value for Cosmos DB connection string. And also I'm using these parameters because those are needed by the patient aggregate store object. And also we're using this connection strings element to set the hospital connection string. So I think we're ready to test this. Let's configure the solution to include the Azure function hospital projector. Let's change it to start. And let's begin debugging session. In the meantime, let's go to the Azure portal. Okay, here we are in the Azure portal because I wanted to show you that I deleted all the items from the patient's container. And also we don't have the leases collection yet. And now let's go to SQL Server Management Studio. Here I want to show you that we don't have the patient's table yet in the hospital database. We only have the patient's metadata table. Okay, I think we're ready now to test. Okay, we have this layout. I know it's quite confusing right now, but bear with me, this is gonna be fun. Okay, so the first thing that we need to do is to transfer the pet to the hospital. So let's click on try it out, execute, and it's responding to 100. As you can see, the Azure function executed automatically. So let's go back to the Azure portal. As you can see now, we have the leases collection. And if we expand the items in the patient's container, we can see this patient-created event, just as we expected. So now let's go to SQL Server Management Studio. Here, let's refresh, and we should have the patient's table. It's right there. And let's see what's the content. And as you can see, we have this state of the aggregate. Of course, it's in a pending state and there's no blood type and there's no weight at this moment. Excellent. Now let's go to the hospital microservice because we want to change the weight for the patient. Let's say 24 kilograms. And let's change the blood type. For instance, let's use DEA-1.3 or 2. Okay, let's execute. And as you can see, the Azure function is automatically executing the projection process. And if we go back to SQL Server Management Studio, you can see that the state is persisted correctly. And now let's admit the patient. Try it out, execute. Let's execute this. As you can see, the status is pending, and eventually the status changes to admitted. So this is important because the eventual consistency is something that you have to manage in the microservices that you build. Finally, let's go to the discharge endpoint and let's execute this command, execute, and again, from admitted to discharged. Eventually, it changes to this new status. In this video, we're going to talk about the API gateway pattern. Before I explain what an API gateway is, let's first identify why it's needed in the first place. When you have several microservices, it would be quite inefficient for client applications to invoke each microservice directly. Since the number of microservice instances and their endpoint addresses could change without previous notice, Just imagine the amount of work for configuring each microservice address in the client application. In addition to that, what do you think would happen if we add more microservices to the solution? Or even worse, what would happen if we deploy microservices that use different protocols, not friendly with the web ones? That's exactly what an API gateway is for. An API gateway is a single entry point for all client applications that want to communicate to the backend microservices. For this reason, instead of communicating directly to the microservices, all external clients' requests go through the API gateway. Then, the API gateway could route those requests to the proper set of services. Regarding external clients, there's an alternative form of the API gateway named the backend for frontend. In this other pattern, you implement separate API gateways for each client application type. For example, let's suppose you have two distinct groups of external clients, mobile and web. In this case, you could implement an API gateway specifically for those mobile users and another API gateway for the web-based ones. This technique allows you to expose a more suitable API for each kind of client. On the other hand, I just mentioned one possible way of implementing the backend for frontend pattern, but you could use any other. Let's briefly touch on some of the pros and cons of the API gateway pattern. First, the pros. As we saw in the previous diagram, we can dramatically reduce the round trips between the client applications and the microservices. As I've already mentioned, there's no need to determine the location of each service. Instead, you'll only need to configure the API gateway location. If we were dealing with microservices that use other kinds of protocols, we would implement those in the backend without hassle. And as I said, you could expose an ideal API for each type of client if you implemented the backend for frontend pattern. Speaking of its cons, being the single point of failure for the entire system might sound scary. However, you could independently scale your API gateway services. You can also combine that with the BFF pattern technique that I mentioned. There are numerous features that API gateways include, but it will depend on which one you use. There are several technologies and brands that you can choose from. However, most of the time, API gateways include authentication and authorization functionality, dynamic routing, API composition, in other words, the capability of aggregating the data received from two or more services, logging and tracing, rate and limiting, that is, prevent further processing of requests if certain conditions are met, and finally, insights and monitoring for observability. In this chapter, we're going to use Ocelot, which is an open source API gateway SDK for .NET. You can find all its related information in its GitHub repo. In this chapter, we're going to add an additional project based on the ASP.NET Core empty template. After that, we're going to add a JSON file named ocelot.json that will include the configuration for the API gateway. Speaking of which, let's see the configuration elements that we're going to use. In the global configuration element, we're going to set the base URL, which is the address where the API gateway microservice is running. Then we're going to use the routes element to add the configuration for each route. What kind of information should a route have? Here, we have to set the downstream and upstream properties for each service. Downstream means the current location and endpoints that a microservice exposes, whereas upstream means how you want to expose that microservice to the outside world through the API gateway. As you can see, there are some things we have to take care of. So let's go ahead and get started. In this video, we're going to implement a new API gateway microservice by using Ocelot. Okay, let's start by creating a new folder named Gateway. And here we're going to add a new project based on the ASP.NET Core web application template. And let's name it wisdompetmedicine.api. And let's put that inside the source folder. We're going to use this time the ASP.NET Core empty template. And let's click on Create. And now we're going to add the Ocelot NuGet package reference. So let's search for that. At the time of this recording, the latest version is version 17. Let's close this. And now we're ready to modify the startup class. Let's get rid of those comments. And here in the configured services, I'm going to invoke add Ocelot. which is inside the Ocelot dependency injection namespace. And in the configure method, I'm going to invoke use Ocelot, which is inside the Ocelot middleware namespace. And let's modify this to Wisdom Pet Medicine API gateway. Perfect. And let's close this file. And now we're ready to add the Ocelot configuration. So I'm going to add a new file named ocelot.json. And here I'm going to paste the basic configuration structure that I took from the Ocelot's documentation website. As you can see, we have the routes collection, and we have the global configuration element that has this base URL property. This is very important because this is the place where this microservice will run on. So actually, we need to configure this, and we actually should know the port number. So let's open up this launch settings JSON file. As you can see, this microservice will run on port 44324, and I'm going to copy that and paste it right here. And now we're ready to add the route configuration. I'm going to paste the basic structure. And as you can see, we have two different kind of properties, downstream and upstream properties. The downstream properties are the actual endpoint structure and configuration where the microservice you're trying to communicate to is located. And the upstream properties are how you would like to expose the routes through the gateway. So for instance, if I want to expose the pet microservice, I know that microservice is running on localhost, and let's see the port number. Let's open up this launch settings JSON file. This is the port number. Let's go back and paste it. Excellent. Now let's specify how the microservice is actually responding to requests. For instance, I know that all the endpoints fall under the pet segment. And that's because if we go to the pet controller class, we can see that we're using this route. That's why, for instance, if I want to, for example, use this name endpoint, that's pet/name. So this is going to be the same. And here the downstream scheme is HTTPS. And now let's specify how are we going to expose this. For this demo, I'm going to use the same pattern. And here in the upstream HTTP method, I'm going to specify the different HTTP verbs that we're using. So I know that we're using post and put as well. Now we're ready to add the routes for both rescue and hospital microservices. And I happen to have the code already here. So I'm going to copy that and paste it down below. This is for the rescue microservice. As you can see, this is running on port 44302. And the hospital microservice is running on another port. As you can see here, I'm specifying the upstream path template differently than the downstream path template. So for instance, if we go to the rescue microservice, we can see that we have the adopter controller, right? And for example, this endpoint is adopter/phone number, but for the API gateway, it's gonna be rescue/adopter/phone number. And the same for the hospital microservice. I'm using this prefix for all the requests. Okay, finally, we're going to modify the program.cs file because we need to add the Ocelot JSON file as part of the configuration. So I'm going to do the following. I'm going to use the web builder and configure app configuration. I'm going to pass this lambda, and I'm going to use this add JSON file, but this time is ocelot.json. Excellent. Now I think we're ready to test this. So before we do that, let's change the startup projects. And I'm going to specify that the Wisdom Pet Medicine API starts with the other microservices. Okay, cool. Let's close this. And now we're ready to test the solution. So I'm going to click on the Start Debugging session. And now the microservices are running, but I created this layout so you can see that we're going to use the API gateway. So I'm going to use PowerShell this time for sending a request. Of course, you can use Postman or any other tool for that. So I'm going to specify the body. And now I'm going to specify another variable that is the body converted to JSON. And I'm going to use the invoke web request commandlet to send that request to the API gateway, specifically to the hospital patient admit segment. So in other words, I'm going to invoke the hospital microservice through the API gateway. So let's execute this. And as you can see, the Azure function responds because it detected the change in the Azure Cosmos DB's change field. Of course, I could change this web request to, let's say, discharge. And eventually, the Azure function runs and it creates the state and it saves the state in the SQL Server database and all the things that I've already mentioned before. It's time for a challenge. The goal is for you to get real hands-on practice implementing the API gateway pattern with Ocelot. Specifically, you should configure additional routes in the API gateway microservice to expose the pet query, rescue query, and patient query endpoints. If you'd like to skip this challenge, join me in the next chapter. We're going to use the following configuration. This table shows the required upstream paths and how they map to the actual endpoint paths we have. When you're done, join me in the next video and I walk you through how I approach this. To solve this challenge, we need to modify the ocelot.json configuration file. This is because we need to add some additional routes right here. And I have the code already in place, so let me paste it. As you can see, this is for the pet query endpoint. So we're using queries /pets/all. And of course, we're using get. And this is the port number of the pet microservice because, as you might remember, pet query is the pet query controller class that is implemented inside that microservice. Okay, now let's implement the code for the rescue query endpoint. Let's paste it. And here, as you can see, we're using queries /adoptions/all. We're using get as well. And this time we're using this other port, which is the port that the rescue query microservice is running on. We can see that in the launch settings JSON file. Okay, let's go back here. And finally, let's configure the patient query endpoint. And as you can see, we're using queries patients all, get, and this other port number, which is the one from the hospital microservice. Excellent. We're ready to test this. So let's click on Start. Here we have the default response from the API Gateway microservice when we request the root route. So you don't have to use PowerShell this time. You can go right here in the browser and type, for instance, queries, let's say pets all. And as you can see, this is returning the data from the pet query. And now let's change this to adoptions all. And of course, we get the data back. And finally, patients. And we can see we're receiving the data from the patient query endpoint. For many reasons, you might want to implement health checks in your applications. That becomes critical when building microservices that are deployed in container orchestrators such as Kubernetes. ASP.NET Core includes health checking middleware and libraries, so you can easily implement this coding concern in your applications. They report the health of an application through an HTTP endpoint that you can configure. There are numerous ways you can use for implementing health check probes. You could, for example, verify if a certain database is available, if the CPU has increased or decreased its utilization, also the memory, the available disk space, verify the existence of a specific file or folder in the file system, or check if a particular process has finished. That said, the way you implement the health checks needs to be aligned with your business requirements. For example, the pet microservice requires the pet database to work. So that could be one of the probes for that particular microservice. If the database is available, then the pet microservice could report a healthy state. But what would happen if the pet database is not available for whatever reason? In this case, the microservice would report an unhealthy state since it doesn't make sense to receive requests. Now, for some hosting scenarios, a couple of health checks are used to obtain the current state of the application or service. Readiness indicates that the service is running, but it's not ready yet to process the incoming requests. In contrast, liveness indicates that the service has crashed and it can continue working until restarted or be fixed. This idea of having two separate health checks makes a lot of sense when you deploy your microservices in a container orchestrator such as Kubernetes, where you can specify a readiness probe path. In this way, Kubernetes can be aware of the microservice availability. In other words, if the microservice can receive requests or not, or if it has to restart the microservice. For example, if we used both probes in the pet microservice, we would receive a healthy response from liveness, but maybe unhealthy or degraded from readiness. Okay, let's open Visual Studio. Let's see how we can implement a couple of health checks here in the Wisdom Pet Medicine system. So I'm going to open up the startup class from the pet microservice because here in the configure services, I'm going to add services.add health checks. And down below in the configure method inside the use endpoints lambda, I'm going to type endpoints map health checks. And I'm going to specify the endpoint. In this case, I'm going to use health. Okay, let's start debugging. And of course, this will navigate to Swagger, but instead I want to navigate to health. And as you can see, this is returning healthy because at the end of the day, this is not checking anything interesting right now. So let's close the browser and let's continue with our implementation. What I want to do is something more compelling. Actually, I want to probe that the PetDB context has access to the database. So for this reason, I'm going to add another NuGet package, which is Microsoft Extensions, Diagnostics, Health Checks, Entity Framework Core. So let's install that. And here, by using the Fluent syntax, I'm going to invoke add DB context check, and I'm going to pass PetDB context. Just like that. And before we test this, let me comment out this ensure PetDB is created method call, otherwise it's going to recreate the database. And let's change the connection string because there's no pets database. Okay, so let's start debugging again. And let's navigate to health one more time. And this time is returning unhealthy just as expected because as I said, there's no pets database. That's why the microservice itself fails. Nice. So next, what I want to do is to add another health check, but this time for the hospital microservice. As you might remember, the hospital microservice uses Azure Cosmos DB to store the events, but we don't have a DB context for that. That's why we can use a DB context check. We need to create a custom health check. So I already implemented the code to expedite this process. So let's take a look at it. For this other health check, I created the Wisdom Pet Medicine Cosmos DB health check class that implements iHealthCheck interface. And here in the check health async method, as you can see, I'm invoking the read account async method from the Cosmos client object. And if this fails, it means that there's no Cosmos DB account provisioned. And here I'm obtaining the container. And if this fails, it means that the Cosmos DB account exists, but there's no database or the container is not created. Finally, I'm obtaining the container properties and I'm checking if the status code is okay, then I'm reporting healthy. Otherwise, I'm reporting unhealthy. And then I created the health checks builder extensions class and implemented this extension method, add Cosmos DB check, and I'm receiving this iConfiguration object. And here I'm instantiating the Wisdom Pet Medicine Cosmos DB health check object. And I'm using this class here in the startup class, right here in the add Cosmos DB check, and I'm passing the configuration object. And let's test this. And of course, let's change the connection string. For example, Wisdom Pet Medicine or something like that. It doesn't matter. So there's something wrong with this port. Let's try again with this Wisdom Pet Medicine Hospital API profile. And now let's navigate to health. And as you can see, this is reporting unhealthy because there's no Cosmos DB with that connection string. Actually, I'm receiving the error right here. But at the end of the day, the hospital microservice is unhealthy. To get the most out of health checks, you might want to pull the data in a dashboard to monitor the entire services in a single place. Even though that's out of scope in this course, I strongly suggest you consider it for your solutions. When building microservices, you should always strive to adopt a good versioning strategy to avoid breaking changes at all costs when evolving your code. Generally speaking, additive changes are safe to implement, but what happens when you apply a breaking change in your code? Thanks to the versioning support in ASP.NET Core, you could easily expose different versions for your endpoints without worrying about breaking the current clients. For example, you could expose a V1 endpoint that receives requests from V1 clients. And also, you could have an additional V2 endpoint that serves the V2 clients. With this in mind, it's easy to see how you could eventually deprecate your old code in favor of the most recent one. Remember that microservices should be autonomous and independently deployable. If you changed a microservice, you would deploy only that microservice and not the clients as well. In other words, it shouldn't be required to update both clients and microservices at the same time. Okay, let's see how we can implement versioning in ASP.NET Core. Let's pretend that Wisdom Pet Medicine requires a change in the rescue query microservice. However, the company doesn't want to break the current client applications and systems, so they want to keep both versions. What I'm going to do now is to add a new NuGet package reference, and this time is Microsoft ASP.NET Core MVC versioning. So let's install that. And now I want to modify the startup class because here in the configured services, I'm going to invoke the add API versioning method. And actually, I'm going to pass this options object because I want to set some properties. The first one is the default version. And this time I'm going to set it to 1.0. And I'm going to assume that if clients don't specify the API version, I'm going to use the default API version. And finally, I'm going to use these report API versions to true. Excellent. Now I want to implement a different query. So this time I'm going to add a new folder named V1, and I'm going to move this request query controller class there. And I'm going to add another folder, and I'm going to copy and paste the request query controller class. And of course, we need to fix those namespaces. Let's do the same for this other one, just like that. And let's implement a different query for version 2. Say that we want the color of the pet, just like that. Okay, now I want to specify that this query controller class is related to version 2. So I'm going to use this API version attribute, and I'm going to pass this 2.0. And let's do the same for the original one. So API version 1.0, just like that. Excellent. So we're ready to test this. So let's start debugging. You'll probably receive an error in the Swagger UI page because it doesn't support the versioning technique I'm using, at least at the time of this recording. You could find in the companion code a complete implementation that solves this problem with Swagger. However, this doesn't prevent us from testing the code. So let's do that. I'm going to change this URL to rescue query. And as you can see, I'm not specifying an API version. That's why I'm receiving the original query results. But what about if I specify the API version with this query string attribute named API-version? As you can see, I'm receiving now the color of the pet. In a distributed application built with microservices, you must consider observability as one of its main non-functional requirements. Because of their inherent complexity, these kinds of solutions are more challenging to deal with, since many things could be happening at the same time. For example, in the Wisdom pet medicine system, different microservices collaborate to execute a given process. Without observability, it's pretty difficult to understand if things went right or wrong, if a process has ended already, or how much time a microservice spent on a task. In this case, your last resort is just hope for the best, but that's something that doesn't scale in real-world scenarios. The OpenTelemetry project is a vendor-agnostic specification and standard that includes APIs, SDKs, tooling, and integrations designed to create and manage telemetry data such as traces, metrics, and logs. Furthermore, telemetry data can be sent to many compatible backends, both commercial and open source, such as Zipkin, Prometheus, and Jaeger. According to the OpenTelemetry specification, a distributed trace is a set of events triggered as a result of a single logical operation, consolidated across various components of an application. A trace is composed of one or more spans, which represent an operation in the system. Spans encapsulate metadata about the operation, such as the start and finish timestamp and the parent span identifier. The system diagnostics classes in .NET contain an implementation of the OpenTelemetry API specification. In addition to that, there are many NuGet packages that extend their functionality to add instrumentation in our ASP.NET Core applications rapidly. To that end, we can collect distributed tracing data in the Wisdom Pet Medicine system, consolidated across the different microservices and components. In order to save time, I already implemented the required code in both the pet and hospital microservices for including their tracing information, since we're using asynchronous messaging instead of direct communication between services. We're going to use Jaeger to visualize the distributed tracing data, and also we're going to use Azure Application Insights. Okay, let's open Visual Studio to see the code. Let me walk you through the code that I implemented. First, let's see the changes that I've done in the pet microservice, starting with the CSproj file, because you can see that I'm using some NuGet packages for both tracing and logging. In this case, for the distributed tracing, I'm using the OpenTelemetry ones, and for the centralized logging, I'm using Serilog for sending the logs to Application Insights and Elasticsearch at the same time. And I also changed the app settings JSON file because, as you can see, I added the Jaeger, Elasticsearch, and Application Insights configurations. And let's open up the startup class because here in the configure services, you can see that I added the add OpenTelemetry tracing method call. This is the place where you specify that you're going to use OpenTelemetry in your application. In this line of code, I'm setting the service name. In this case, is wisdompetmedicine.pet.api. And also, as you can see, I'm registering some exporters, which are the backend platforms that support OpenTelemetry data. In this case, I'm going to use Application Insights and Jaeger. And also, I'm telling the OpenTelemetry components that I want to track ASP.NET Core, the HTTP client, and the SQL client as well. And finally, I'm registering this as the pet-API source. This is important because this string is going to be used in a moment. So let's open up the pet application service class, because this is the place where we send the integration event message to Azure Service Bus. Here, I implemented this propagate tracing method that propagates the tracing data by using the OpenTelemetry API. As you can see, I'm using here the pet-API string, and I'm using that for registering this activity source. And at the end of the day, this is used by this publish integration event async method call. And as you can see as well, I'm using the logger object for logging the message that we're going to send to Azure Service Bus. So now, what about the hospital microservice? So let's open up the CSproj file. You can see that I added the OpenTelemetry NuGet packages as well. The application settings JSON file also has the Jaeger, Elasticsearch, and application insights configurations. And here in the startup class, I added the add OpenTelemetry tracing, just like before. Actually, it's the same code. The difference is the source, as you can see. And let's open up this pet transfer to hospital integration event handler class, because as you might remember, this is the place where we receive the messages from Azure Service Bus. So here, down below, I added the propagate tracing method. Basically, this is extracting the tracing data context to start another activity named hospital consumer. So, okay, this is great. Now let's go and let me show you Docker for Windows, because as I said, I'm using Jaeger, but also I'm using Elasticsearch and Kibana for visualizing the logs that we're sending to Elasticsearch. So as you can see here, this is running the Docker containers for Jaeger, Elasticsearch, and Kibana. Now let's open Firefox to navigate to the proper pages for those platforms. Here in Firefox, you can see that I'm using Jaeger in this port, and also here I have Elasticsearch and also Kibana. So I already made some tests, but let me show you how this works by executing the transfer to hospital command. So let's go back to Visual Studio. And here we're going to start a debugging session for the entire solution. And here we are in the Pet Swagger UI. And here I'm going to click on Transfer to Hospital, try it out, execute. And of course, this is returning 200. And let's go back to the other Firefox instance, because here I want to show you the traces for that particular request that we created. So here I'm going to select the Pet API microservice. As you can see, we have both pet and hospital. And let's click on Find Traces. And here we have this one that has 4 spans. And as you can see, this is the entire tracing for that particular command. So it started with the transfer to hospital, then it queried SQL Server to obtain the information about the pet. And then we executed the pet publisher activity. And then after that, the hospital microservice ran the hospital consumer activity, as you can see. This is the entire trace for that particular command, and the duration was 1.85 seconds, with a total of 4 spans, as you can see here. What about the logs? Okay, so let's go back to Kibana. And here I'm going to search for sending message. As you can see here, this is the log that has the information about the message that we're sending to Azure Service Bus. And finally, let's open the Azure portal so we can see the logs in Azure Application Insights and also the tracing information. Here in the Azure portal, we can see the tracing information in many different forms. For example, the application map shows a topology diagram with all the components and their dependencies. On the other hand, we can see the logs, and we can even query them by using the KQL language. For example, I'm querying the custom events table, here, and we can see the sending message record that we have here. We can inspect all the different properties, and we can see the body of that message that we sent to Azure Service Bus. It's time for the last challenge of this course. The goal is for you to get real hands-on practice implementing cross-cutting concerns in your microservices, specifically health checks, versioning, and centralized logging. If you'd like to skip this challenge, join me in the next chapter. All the cross-cutting concerns are going to be implemented in the hospital microservice. First, we're going to add a health check for the hospital DB context. This will complement the existing custom health check that verifies the connectivity to Azure Cosmos DB. Second, we're going to add another version of patient query. This second version should return a different query result than the previous one. Third, we're going to send to the log the message received when transferring a pet to the hospital. When you're done, join me in the next video and I walk you through how I approach this. Let's begin by implementing the health check for the hospital DB context object. So I need the Microsoft Extensions Diagnostics Health Checks Entity Framework Core package reference that I have here in the pet microservice. So I'm going to copy that and I'm going to paste it right here. And in the startup class, I'm going to write down below the add Cosmos DB check. I'm going to execute add DB context check, and I'm going to pass hospital DB context, just like that. And as you might remember, the endpoint is health. So we're ready to test this. So here in the browser, let's navigate to health. And as you can see, this is returning healthy because the hospital DB context is able to communicate to the database. Now, let's implement the versioning. For that, I need another NuGet package, which is implemented here in the Rescue Query API. And this is the NuGet package that I'm going to use. Let's copy that and let's paste it right here. And I'm going to open up this startup class again, and I'm going to execute services at API versioning. And also I'm going to paste the code right here. As you can see, I'm using the default API version, also the assumed default version when unspecified, and the report API versions. So now I need to create an additional version for the patient query controller. So I'm going to create a new folder here named V1, and I'm going to move the patient query controller class there. And let's create another folder. And we're going to copy and paste the patient query controller class here. And we need to fix the namespaces just like that. And also we need to specify the API version. This is version 1.0, and this other one is version 2.0. And of course, I need to change somehow the query. So let's do that. I'm going to paste the query right here. In this case, I'm projecting the sex of the pet to a string representation. That's the difference between this version 2 and version 1. Okay, so we're ready to test this. As I've mentioned before, you'll probably receive an error in the Swagger UI page, but that doesn't prevent us from testing the code. So I'm going to execute patient query. As you can see, this is returning the number. And if I say API version 2.0, this is returning the string representation. So let's close the browser and let's go back to Visual Studio. Let's now implement the logging. So here I need to add the Serlog NuGet packages, which I have right here. I'm going to copy this and I'm going to paste those package references here. And also we need to change the program class. So I'm going to copy the create host builder from the pet microservice, and I'm going to replace that here. And let's fix the namespace, and we're done. Now, in the pet transfer to hospital integration event handler class here, we're injecting the logger already. So here, before propagate tracing, I'm going to invoke log information, and I'm going to say something like receipt message and the body. And of course, I need the $sign. And we're done. We're ready to test now. So let's change the startup projects here. And we're going to start debugging. And here in the Pet API Swagger UI page, I'm going to execute transfer to hospital. And now we're going to verify if the log is in Kibana and also in the Azure portal. So here in Kibana, I'm going to search for received. And as you can see, we're receiving that message already. And let's go to the Azure portal. And here in the application insights resource, let's go to the logs section. And here I'm going to use the custom events. And of course, there are thousands of events. That's why I'm going to filter that where name contains received. And as you can see, we have the logs there. Well done for making it this far, and thank you for joining me in this course. At this point, you should have a solid understanding of some of the advanced tactics that you can apply to your microservices solutions. I'd recommend you continue learning about microservices and their related practices and principles, including security, containerization, and deployment through CI/CD pipelines. You can find fantastic training courses here in the LinkedIn Learning Library. Also, I strongly recommend you take a look at the Distributed Application Runtime, which is an open source, event-driven, and portable runtime for building microservices. It allows you to solve many challenges such as state storage, dynamic discovery of services, and message brokering. I hope you've enjoyed this course as much as I've enjoyed creating it for you. If you do, please let me know. You can find me on Twitter and LinkedIn. As always, thanks for watching, and I'll see you next time.